Hi, my name is Joseph Cao. I'm an MSX candidate in Stanford GSB, leading the CircuBat team to revolutionize second-life batteries by unleashing their reliability and performances through innovative testing solutions. Imagine having more than 40 days of temperature higher than 40 degrees Celsius in Spain, more than 1 month of wildfires here in California, and seeing 15% of Bangladesh go underwater. This will become the reality if we cannot avoid the climate tipping point. To achieve the 2 degrees Celsius Paris Agreement, battery plays a significant role because they effectively decarbonize the energy and transportation sectors. To accelerate the energy transition, the US government rolled out the Inflation Reduction Act to incentivize the battery and EV manufacturers with more than $70 billion of investments. This effectively fueled the battery demand in the coming years. However, by 2040, we can only meet 40% of the demand due to the shortage of the critical material supply. To mitigate, we can recycle or repurpose batteries, and fueled by the ERP and battery waste management regulations, the TAM of these industries has already reached more than $10 billion, and they're expected to grow to more than $70 billion with higher than 20% CAGR in the next decade. What's very interesting is that across different market reports, you see that the growth rate for repurposing is higher than recycling. So why is that? Through many interviews with the stakeholders in the battery value chain, we learned that this is caused by the shift from NMC to LFP batteries in the coming years. By 2035, LFP chemistry will become the mainstream. LFP stands for the lithium iron phosphate battery chemistry. They have 10% lower energy density, much lower critical material content with only 30% of the recyclable value compared to NMC. This is why many LCA and techno-economic assessments show that repurposing LFP battery is more profitable and eco-friendly than recycling. So this presents a very unique opportunities for LFP battery repurposing in the coming years. In addition to the market and financial implication, assume a 90% repurposing rate. By 2030, we can mitigate more than 3 gigatons of carbon dioxide emission by decarbonizing the battery value chain. In addition, several million tons of battery waste can be diverted from toxic landfills that impacts more than 55 million Americans. And lastly, billions of people in the emerging market can have access to affordable clean energy to avoid the cycle of poverty. However, there remains many challenges to scale battery repurposing. When the repurposer receives large amount of batteries, it's very time consuming to test and sort them, and the inaccurate cell level data leads to unreliable and unsafe second life batteries that's not suitable for all kinds of applications. What happens is that the repurposers need to first test the pack level state of health using EIS or BMS technology. These tests usually takes minutes to hours. However, it's impractical to repeat the same test for hundreds and thousands of cells in these packs. So what the repurposer usually do is to selectively sample the battery cells. However, this leads to problematic repurposing because you cannot identify all the poor performing batteries that significantly impacts the performances and safety of the second life battery. Without the accurate cell level data, we cannot reliably warranty the second life batteries for different applications. And at CircuBat, we want to change that with our revolutionary magnetic Hall sensor arrays, where we can simultaneously measure the state of health of hundreds to thousands of battery cells in the pack in minutes. With this approach, we can accurately identify all the poor performing cells in the packs, replace them, and repurpose the battery packs into healthy second life batteries applications. With a machine learning algorithm, we can predict the performance, lifetime, and safety very accurately to reliably warranty them for different application in different channels. So why us? We are battery circularity enthusiasts with very relevant and complementary skill sets. Summer Shaw has a lot of insights about the battery recycling regulation and policy landscape based on her experiences leading the Energy Transition Initiative at DOE and the state of New York. I gained my knowledge and skill sets in material science and energy storage from my PhD at UC Berkeley and the Zero Waste Initiative in Apple. Matt is a hardware software integration expert with strong expertise in battery recycling and mechanical engineering. And lastly, Anand is our advisor on sensor, and the Hall effect sensor is his invention in the Professor Senexis lab. So with that, I hope I've convinced you how important battery repurposing is to help us achieve the climate goal in the coming years. And we offer the unique technical solution and skill sets to tackle this daunting challenge to ensure a more sustainable